Welcome to Homework Lib.
Hi, so over here we're going to calculate what is going to be the volume of a solution of NH4 plus that we need to add to a buffer that is going to have equal concentrations of NH4 plus and NH3. So we're going to have a buffer that has an initial pH equal to the pKa of this system. But we want to add some NH4 plus in order to generate a buffer with a pH equal to 9.04. And the total volume is going to be 118 milliliters, which is the same as 0.180 liters. Now, over here, the only value that is missing for us to solve this problem is the concentration of the NH4 plus solution that we want to add to our buffer. So without this concentration, we cannot finish the problem or get the final result. But here I can outline what is going to be the general procedure, and then you can ask about that concentration, and we're going to see how everything goes. Okay. So in this case, we have the restriction that the total volume is going to be 118 milliliters. We know that the pH needs to be equal to 9.4. So the information that we require is the value for the pKa. We can calculate pKa as pKa plus pKb is going to be equal to 14 always. And the value that is given to us in this problem is the Kb of NH3, which is 1.8 times 10 to the minus 5. If we do some calculations and take the minus logarithm of that, remember that pKb will be equal to minus the logarithm of Kb, we're going to arrive that the value is equal to 4.745. So the value for pKa for this system would be equal to 9.255 directly, just applying these two equations. So now what we know is that the pH is given by the Henderson-Hasselbalch equation, which tells us that pH is equal to pKa plus logarithm of the concentration of the conjugate base, in this case NH3, divided by the concentration of NH4 plus of the weak acid. Now we can replace the values. 9.04 is going to be equal to 9.255 plus the logarithm of the ratio of concentrations. Now we're going to proceed by finding the value for the ratio of concentrations. So over here we're going to have concentration of NH3 divided by concentration of NH4 plus, and this is going to be equal to 10 to the pH minus pK. In this case, the value that we have is 10 to the minus 0.215. Over here, this is 0.4, not 0.41. For some reason, it doubled the line on the 4. Okay, so now what we need is to calculate the volumes of each of these guys. So we're going to have the concentration of NH3 and concentration of NH4. Each of them is going to be given by the following equation. The concentration of NH3 is going to be equal to concentration of the buffer times volume of the buffer added divided by the total volume. Notice that the first section over here is going to be equal to the amount of mole of substance of NH3 that I have. On the other hand, for NH4 plus, the value is going to be concentration of the buffer times the volume of the buffer plus concentration of the NH4 plus solution times the volume of the solution that we need to add, and all of this divided by total volume. If we divide one by the other, let's do the division over here, notice that the total volume is going to cancel out. So this ratio, let me erase the equals on both sides, and we're going to give only one. After dividing one by the other, we're going to get concentration of the buffer times volume of the buffer divided by concentration of the buffer, volume of the buffer, plus concentration of NH4 plus times volume for the solution. This is now going to become an equation with 10 to the minus 0.25 to the hand. And this is going to be concentration of the buffer, volume of the buffer, divided by concentration buffer, volume buffer, plus concentration of the solution times volume of the solution. So over here we can find an equation for both of them, and this is going to be a linear equation. We're going to multiply the denominator by the left-hand side, so 10 to the minus 0.25 concentration buffer, volume buffer, plus 10 to the minus 0.25 concentration NH4 plus volume of the solution. This is going to be equal to concentration buffer, volume of the buffer. So we can calculate over here, isolating the value for CV and BB, we can put everything to the right-hand side, everything with volume of the buffer. On the left-hand side, we're going to end up with concentration of NH4 plus times volume of the solution multiplied by 10 to the minus 0.25. And on the right-hand side, we're going to have concentration of the buffer, volume of the buffer, times 1 minus 10 to the minus 0.25. Okay? So now we have a system of equations with the volumes, and the only information that we're going to require is going to be the concentrations. Additionally to this, we know that the volume of the solution plus the volume of the buffer is going to be equal to 118 milliliters, or 0.118 liters. So by solving this system of equations, you're going to be able to get your answer. So over here, what I'm going to do is solve it, assuming that the concentration of the buffer is 1 molar, and assuming that the concentration of the NH4 plus solution is equal the same 1 molar, and we're going to see what happens. Under this assumption, the system of equation now reads 10 to the minus 0.25 times the volume of the solution is equal to volume of the buffer times 1 minus 10 to the minus 0.25. The other restriction was volume of the solution plus volume of the buffer is equal to 0.118. So we can solve this system of equations by whatever method you prefer. So for example, let's isolate volume of the solution on the first equation. This is going to be equation 1 and this is going to be equation 2. So from equation 1, we're going to get that the volume of the solution is equal to volume of the buffer times 1 minus 10 to the minus 0.25 divided by 10 to the minus 0.25. Well, 215 was, right? For some reason, I've been writing 0.25 instead of 0.250. So let me correct that over here, here, and here. Okay, so now the equations are correct and consistent. Perfect. And now we're going to substitute this value in equation 2. So now equation 2 is going to read volume of the buffer times 1 minus 10 to the minus 0.215 divided by 10 to the minus 0.215 plus volume of the buffer is equal to 0.118. We can solve for volume of the buffer, which is going to be equal to 0.118 divided by a factor that is going to look quite strange, but it is what it is. 1 minus 10 to the minus 0.215 divided by 10. Well, actually over here, it would be multiplying times 10 to the minus 0. Yeah, sorry about that. Let me make some space over here to make it accurate. So we would get that the volume of the buffer is going to be equal to 0.118 divided by a very big factor that is 1 minus 10 to the minus 0.215 over 10 to the minus 0.215 plus 1. This comes from factorizing volume of the buffer in this equation from this part and solving for this. So the volume of the buffer would be 0.0 0.72 liters, which corresponds to 72 milliliters. So that means that the volume of the solution would need to be equal to 0.118 minus this quantity, or directly we can put 180 milliliters minus 72, and we would get that the volume of the solution would be 46 milliliters of NH3 plus that we need to add to our buffer in order to achieve the desired pH under these circumstances. And the volume of the buffer that we would require to add would be 72. So it would be volume of the buffer. This would be volume of the NH4 plus solution. Of course, this is assuming that the concentrations are equal to 1 molar. If the concentrations are different to that or were given in a previous problem, you can employ this system of equations and just replace the values for concentrations of buffer and of NH4 plus and continue solving. So that would be all. Thank you very much and have a good one.